Okay, so good afternoon, everyone. So I already sent this SMAT code. It's a three-story, three-bay frame analysis of non-sway frame. Okay. Then to explain further the coding. So since non-sway, we will not activate the displacement, lateral displacement, no? And again, it's non-sway because the loading is symmetrical. The the cross sections are well, equal, and the frame is symmetrical also. There, okay. So this again are the node numberings. We have 16 joints, no? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we have 21 members. And then this is take a look at the difference now in the coding for non-sway and sway frame. For the non-sway frame, I only included the the rotation, which are four, okay, four, six, okay, six here, eight here, okay, 12 here, 14, 16, okay, 20, okay, 22, 24. No? So how many unknowns we have for non-sway? We have 1, 2, 3 times 4, 12 by 12. And these are the code for those unknown displacement: 4, 6, 8, 12, 14, 16, 20, 22, 24, 28, 30, 32. Okay. Unlike with sway, the unknown will be much larger, no? Much, because we will also consider 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 19, 20, so on and so forth until 31, 32. Okay. Now, let me try to. So I think I'm the host now. This one. Okay, so we have this three-story here. One, now, the numbering of members are this one, two, three. Can you still hear me, no? Please, ano na lang. 4, 5, 6, 7, 8, 9, 10, 11, 12. Then the girders are 13, 14, 15, 16, 17, 18, 19, 20, 21. Now, this will be a bit tedious, but for the sake of generating the structure stiffness matrix. So what's our K1? The code. K1 code will be, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh, did I miss? 19. Oh, this one. 17, 18. It should be 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. For K1, so the codes are 1, 2, 3, 4. For K2, 3, 4, 5, 6. For K3, 5, 6, 7, 8. For K4, 9, 10. 11, 12. K5, 11, 12, 13, 14. K6, 13, 14, 15, 16. K7, 17, 18, 19, 20. K8, 19, 20, 21, 22. K9, 21, 22, 23, 24. So on and so forth, no? Until we have, say, K, for, let's finish the column now. K12 for the column. That will be 29, 30, 31, 32. Now, say we're talking non-sway. Again, all rotation only. So I'll encircle all the rotations. That will be, what will be the active here? Again, 4, 6, 8, 12, 14, 16, and so on and so forth. These are all the active or the unknown rotation. So in terms of the code in each element stiffness matrix, we need four. I mean, we're getting four, six. We wanted to get 8, 12, 14, 16, 20. Okay, 20, 22, 24, until for the column 32. So as you see, there's a trend, no? There's a pattern. We will only need, sorry, the here 4, 6, 10, 12, 12, 14, 14, 16, 18, 20. No, no, no. Sorry, sorry. 4, you need 4, 4, 6, 6, 8. We will not need 10 because it's a support. No, this is a support here. 10. Okay. Next, 12, 14, 14, 16, 18. We will not be getting 18 also. It's support. It's a restraint. 20, 22. We need 20. So as you see, the pattern is typically for columns without restraint, no, without without fixed support, we will just be getting the second and the fourth element, right? While for columns with fixed support, we will need the fourth element. Right? That's why I'll show later the SMAT code 8, 20, K9, 24. And so we also need 30 and 32. Yeah. K9, 22 and 24. Okay. Yeah. So that's each K. No? Now for BU matrix, say for the BU, remember BU is the no, the location, no. So for example here, member 1, what is the location of the element that we will need? So as you see, K1, uh, the encircled one is 4. So we need the fourth element of K1. For K2, we will need the second and fourth. Second, fourth. For K3, same, no? Second and fourth. For K4, we will need also K4, that's in the no, that's in the ground. We need the fourth. For K5, we need the second and fourth again. For K6, second and fourth, okay, and so on and so forth, no? Then for the BP matrix, the destination, no? The destination. So I'm just, no, I'm just sampling on the column first, no? For the for the destination. So I'll rewrite down again all the code 4, 6, 8, 12, 14. We need 16. We need 18. No, no, 20. We need 22. We need 24, 28, 30, 32. These are the code. Now, what's the destination of this code 4 here? This code 4, this one, to our S. So that will be the first element, right? The destination of 4 and 6, that will be first and second. So that will be 1 and 2. The destination of 6 and 8, second and third, right? The destination of 12 here, this one, 2, 3, 4. It's fourth. The destination of 12 on 14, 1, 2, 3, 4, 5. So 4 and 5. Okay, so so on and so forth. Okay. And there's a pattern. Since there's a pattern, it's better to make a code. Make a code out of that to automate generating the structure matrix. Okay. Now I'll be so I'll stop this for a while and proceed to our SMAT code. Okay. So this is now the corresponding SMAT code. Okay, where is that? So this is red now because the code is not perfect. My code is not perfect no, because there's a problem in the girder. No? Because as you see, this 3, 4, 11, 12. No? This 3, 4, 11, 12. It needs to be consistent. No? So what the code right now, no, so far, it generates something like and this one 4, 6, 6, 8, 12, 12, 14, 20, 22. So so I need to manually update this, no? Because I will still check if this is consistent with what is what should be no obtained in my uh, stiffness matrix. But at least I've already explained the pattern. So this pins threads because you should yeah, watch out on the on this. So when I update this red one, basically I copied this ano. I think I copied this, no? Then try to edit, no, some information here. Let's take a look later. Okay, so the red and the yellow ones are important. So S1, this is ano, 1 to 12 because I have 12 unknowns. Okay. Then this SS are again the unknown displacements. Okay, 4, 6, 8, 12, 14. Oops, where's that? Okay, so that is consistent. 4, 6, 8, 12, 14, 16, 20, 22, 24, 28, 30, 32. Okay. Next. Okay, the green one is so this is now my BU. As you see, that this is what I'm explaining earlier, the pattern. So four, these are the elements that are fixed on the ground, the columns, no? Because we only need the fourth data. Say the code here is a sample. Let's sample this. 25, 26, 25, 26, 27, 28. Okay, since none sway, we don't need this, the first and second element. We don't need this, the third element, because that's the lateral displacement. We only need this, the fourth element. Okay, so therefore these are four columns. And the rest are four columns, 2 and 4 girders. Right? For the girders, we only need the second and fourth element, right? We we don't assume there will be a vertical displacement. Okay, why no vertical displacement? Because it's um, actually rigid, no? So there's a negligible axial deformation. Okay? So that's BU. For the BB matrix, so again this is in red because there's a there's something I need to check on the code. And as you see, this is what I discussed earlier. Uh, column 1, I only need 1 because its location, oh, sorry, because my, siguro I'll paste this, 468. Because that means, remember, the first code is 1, 2, 3, 4. No? And again, for this first code is for column, no, fixed on the ground. We only need the fourth element. And 4 is the first element on our structure stiffness matrix. Then second element is, that's why I need to, that's why you need to see the numbering. Yan, okay? And then for the second element, we need 4 and 6, right? So that is first and second on our structure stiffness matrix. Okay. For the third element, this is for the third element. Okay, so BB is in the location 2, 3, so third element. And we'll go back to the column on the ground, number 4 here, this one, member 4. We only need the fourth element. What's the code for that? 12. It's 12 here. And which the location is on the fourth. That's on the fourth element on our S matrix. Okay, so on so forth. So once you have BU and BB, we can now generate the S matrix. But before that, we need to transform the member stiffness matrix, di ba? Because this is a transformation matrix for column, while this one is identity matrix, transformation matrix for girder. Yeah. So you see, I only applied this transformation matrix from member 1 to 12. Here. And member 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because they are all columns. Okay? Then I applied this transformation matrix to all the girders, horizontal members. Yeah. So that's why my loop here is from 14 because because I already established member 13 eh. Ito, this one. Therefore, the transformation matrix will be applied from the 14 all the way to 21. Okay. So as a heads up, if you do the same code, that will be beneficial. Eh, no? Na group first all the columns, then group next are the girders. So that should be consistent. Eh, no? So you need to be consistent. Okay, so then you get the global stiffness matrix for each member. Yan. T's, again, remember the formula. This is T transpose K local times T. That's the formula. Okay. Next is, yeah. So we have, maybe I should make this yellow. Yellow. Okay. So why do I have fix and force here? Because my STAAD is here. View. Where's my loading? Yeah. Okay. And its length is 4 meters. So if you apply the fix and forces here, WL squared over 12, right? So substitute 5 here. 5 times 4 square over 12, you will get 6.667. Okay? 6.667 kilonewton meter. That's why my fixed and force here is this. 6.667. Okay? And that is, again, consistent to our numbering, no? So remember that is 2, 4, 6, 10, 12, 14. Where's my SMAT? Oh, sorry, my whiteboard. There. Okay. So if you will lay down our p vector, diba? The code is should be consistent with this. It should be consistent with this. So it should be 4, 6, 8, 12, 14, 16, 20, 22, all the way 32. Okay. So the only non-zeros are corresponding to what what code? 20, 28. This is 4 and 12. Because they are the only loaded code, loaded nodes. Sorry, yeah, loaded degrees of freedom. Okay, so 412, so not, this will be non-zero. 412 is non-zero. 20 is also non-zero. 28 here is also non-zero. So we have four non-zero element in our P vector. So, and 4 is located at the first element. So that is negative 6.667. 12 is located on 1, 2, 3, 4 on the fourth, 6 positive. 20 is located on the on the seventh. 1, 2, 3, 4, 5, 6, 7. Okay, consistent, no? And lastly, 28 is located on the 10th, no? 6.667. Okay, so we now have, P is equal to SD. We now have P vector. S matrix will be generated automatically. And therefore, we can now get our D. Then this is our S matrix. Okay, so it's a banded matrix. Now, again, to those who already have numerical methods, one way to solve banded matrix is by, it's a we call this a tri-diagonal matrix, so you can solve it using Thomas algorithm, wherein you will not be using the zeros, so that saves up memory in your computer. And using this formula, we can now get D, and all the unknown displacements are of course rotation, because we only have rotation degrees of freedom. And this code is for generating the uh, member forces. And these are all the member forces. Okay. And I think I've already verified this. 1.44. Maybe let's try. I've already obtained this. 1.44. So this is member 1, right? On our labeling. 1.33, 2.85. Okay. 1.33. So 1.44. Sorry, this should be the. So we're on bending. No? 2.85. And this is the shear, 1.44. Okay. So I'll click on here to get the shear. And 1.39. So almost 1.44. Okay. So consistent, no? The displacement of member 1 is only 0, negative 0.0034, because the rest are zeros, right? You have restraints on the ground and no lateral displacement. Okay. So in short, using this SMAT code, you can theoretically, no, you can analyze high rise, right? Because you can just input the members here, number of joints, okay, and define the matrix, your expected S matrix, and then this one may be tedious part because it is the incidence, the member incidence. No? Then define the length of each member. So again, to be consistent, since I only defined the columns first, these are all trees because these are all the columns. And these are all the girders. Okay. So that means all the yellows are input. No? So the constraints, okay. Okay. So let's now proceed with sway. No? So that means let's analyze this frame considering lateral load. Okay. File, open, sway. Okay, so it's actually it's the same model, no? I only changed the loading. Yan, no? So instead of gravity load only, I now included lateral load, 40, 20, and 30. Okay, okay, 40, 20, and 30. Now you can now realize that aside from the rotation degrees of freedom earlier, so this is 12 by 12, right? Because you have three rotations here multiplied to four columns, so that will be 3 times 4, 12. Now, since we have now lateral load, we now expect our frame to behave something like this. Therefore, we can now consider the lateral displacements. Now, to, to assume a rigid diaphragm, because the rigid diaphragm assumes that with the introduction of rigid diaphragm, the displacements here is equal to the displacements here. So this is also delta 1. This is delta 2. This is also delta 2. Okay. So that means our code here, remember this is 1, 2, 3, 4, 5, 6, 7, 8. We will now treat all the this lateral displacement on second floor as code 3. All the lateral displacements on third floor, code 5. All the lateral displacements on fourth floor, code 7. So aside from the unknown 12 rotational displacement, we will include three, three sway, three lateral displacement. So therefore our S is now 15 by 15. Okay, so this will now be 15 by 15. Okay, this is 15 by 15. Now I'll show you my whiteboard. This is now my new, where's my new coding. As you see, so earlier, okay, so I have 4, 6, 8, 12. So this is 4, 6, 8. Then these are all equal. Okay. 14, 16, and these are all equal. Okay. Then I added 3, 5, and 7 as the lateral displacements. Okay, for sway frame. That means in my code, as you see in my code, it's automated. No, there's an it's automated that uh, this joint will have a code 11, 12, 13, 14. So I need to. So this is the explanation for the red columns earlier. So I need to tweak the code such that this 3 will be equal to 11, to 19, and to 27. This 5 will be equal to 13, to 21, and 29. This code 7 will be equal to 15, 23, and 31. Okay? Okay, so let's now proceed. This is the corresponding code for that. Click on the sway. Okay, so still the same, no? Same member, same joint. Now, maybe how can we view these two side by side to differentiate, no? This is the non-sway. Okay, as you see here, can you see the difference now? So for the non-sway, I assumed an initial null matrix of 12 by 12. For the sway, I now make it 15 by 15. Okay. The incidence is still the same. No? The length is still the same, inertia the same. Now, so of course, the constraint will be different. This is my constraint, while this is the constraint for the non-sway. Hmm. Ah, yeah, they still the same pala because it's a fixed support. Okay, same. Now for this is the update. Yeah, okay. So as you notice here, let's take a look again. So for this is for non-sway, this is for the sway. Now for non-sway, as you notice, 4, 4, 6, 6, 8, basically even numbers, no? Because it's all rotation. 12, 12, 14, 14, 16. Now take a look at the sway frame. There's an addition, no? For the member 1, first member, I now need 3 and 4. Maybe I'll change first the color for you to see. Yeah. Right. So for non-sway, non-sway and then sway, I only need the rotation. For sway, I now need 3 and 4. The lateral and the rotation. Okay. For the second member, I only need the rotation, the 4 and 6. It's the column, no? The rotation there. For the second member in sway, I will now need all DOF 3, 4, 5, 6 because that column can now displace laterally here. It can now rotate, and here it will displace also here, and it will also rotate. Right? For member 3, again rotation only 6 and 8. For member 3 here in sway, it's the third floor, no? It's lateral displacement, rotation, another lateral displacement, rotation. So I need all the elements. Okay. Then go back to, should draw like this here. So this one, member 4, here. We're here. Member 4. Okay. So I only need the rotation and lateral displacement because it's fixed on the ground, right? So I only need two, the lateral displacement and rotation, right? Take note of the code. That's why it's red earlier. I manually I manually type 3. It's saying that the displacements here, although the code in this column is not 3, I manually input 3 here. I manually input 3 here to instruct the code that the lateral displacements here is the same to the lateral displacements here. That's the explanation there. Now for the member here, so I'll be needing all the elements again, all the code again because it's on the second floor. So 3 lateral displacement, rotation 12, code 12, 5 lateral displacement. So I manually input 5 to dictate that this is originally the code 5, right? That this code 5 is the same lateral displacements on this location. Okay, so that's the idea, no? Then rotation 14. And on the third floor, 5, 14, 7, 16. Now I'll go back to the column on the ground again. I only need the rotation and lateral displacements. So I need, so as you notice, it's 3 again. No? This again, code 3, and rotation is code 20. Okay, so on and so forth. Now, if you notice here, these are all girders. Okay, so to be consistent now, 1, member 2, member 3, member 4, 5, 6, 7, 8, 9, 10, 11, 12. Because our girder started number 4, 13. 13 all the way to 21. Okay? So that should be consistent. And as you notice, I only need rotation because I don't have vertical displacements on the girder because we are actually rigid. No expected uh, axial deformation on the column. So that explains the the different color here. Because my code so far generated this. Yan. Because that the coding is manual, is automatic. I cannot generate three here. No? Maybe I'll tweak something no, later. I think I spent about 4 days doing this code. Doing the, no, no, the improvisation of the on the code because the code is already established on my module. But to automate further, no, to upgrade further, took me 4 days. Then, yeah. So as you notice, for example, here, as you notice to explain, no? 0034, okay, 3456, okay, because 5678, okay, but my code generated 1112. That's the one I tweaked, no, I manually input because there's already an established code for that member 11 and 12. Okay, and 11, 12, 13, 14. Yeah, so I input manually 3 and 5 here instead of 11, 12, 13, 14. So yun lang, no? Next is the rest are important, no? The rest of the code I will not explain further, no? And this is the, what is SS? 3, 4, 5, 6. Yan. So take a look at the difference, no, in our this SS matrix. This is the displacement, no? 4, 6, 8, 12, 14, 16, 20, 22. For the non-sway, because we are already 15 displacements, and 3, 4, 5, 6, 7, 8, and so on and so forth. And what else? BU, where is my BB matrix? Yeah, okay. Yeah, so this is the BU matrix here, and let's compare the BU matrix here. Okay, okay. As you notice, the BU matrix in non-sway, it's only 4 here because rotation only. For the member 1, I need lateral and rotation. Okay. For member 2, I need all the codes, all the datas there, 1, 2, 3, 4. While for non-sway frame, I only need the two datas. Okay. So that's the difference, no? Yeah, as you notice, that no, no, that changes in behavior of your frame. This is this is the implication in your S matrix. So here I only need one data on my member 4, but now I need two datas because it's already sway. Okay, on member 5 I only need two datas because no sway. For member 5 in sway frame, I already need all of the datas there. Okay. While for the girders, it's the same. No? It's the same. No? Two datas. You only need two datas. Because again, no vertical displacement because no axial deformation on the column. Only rotation. And similar story with the because my code is generating this. So is that so? Yeah, my code is generating this. So I need to tweak. I think 1, 2, 3, 4, 3, 4, 5, 6, 1, 7, 1, 7, 3, 8. Yeah. Uh, the only problem here is this is my code, but it should be this. The problem is here. This is small difference. No, my code is here. For example, 1378. I'm generating 1378, but what I need is 1738. No? Because unfortunately, I made the code such that I I will rearrange all the numbers in increasing order. No? So that's the problem. No? While in reality, it should be not. No, it should be depending on the. Okay, that's the problem. Maybe I need to tweak that later. So that's the only ano pa, improvement that I need to work on. Okay, the rest are the same na. No? The rest are the same. Okay, for example, for member 1 here, the forces are this. Now for here, because we are now on sway, and yeah, we have lateral load. So this is my member force, 190566. So maybe I'll put it here. Open the stat. Oops. So post-processing, and then, yan. So as you see, this is the lateral displacement. Okay, what's the displacement on 238? 238. 141 lateral displacement, no? 273 and 355. 141, 273, 355. Let's see what's the displacement we got. This one. 128. I'm getting 0.128. So STAAD is getting 0.141. Okay. For displacement 4, as you notice, no? I want you to see this. Remember, this is our building. Ay, what happened? So therefore, the lateral displacement of member 1, member 4, 4, 5, 6, member 7, 8, 9, 10 will be the same, no? Because we assume uh, a rigid diaphragm, no? And by tweaking, no, by by enforcing that displacement 3 will be present on this elevation, no? So as you see, displacement 1, 1288, displacement on member 4, 1288, on member 7, 1288, and member 10, 1288. Okay, so they're the same. Okay, makes sense. For displacement 6, 4, 5, 6. So, so this will be, let me redraw. So displacement 6, member 6. So for this is, I'll redraw again. So this is member 4, member 5, member 6. And this is the lateral here and lateral on the roof. So I have 0.25 and 0.33. Okay, 0.25, 0.33. What did STAT get? Yan, 0.35 and point 238. 238. 1, 2, 3. Yeah. So 0.27, I got 0.25. STAAD gets 0.27. I got 0.33. STAAD gets 0.355. Very, very near, no? For a millimeter tolerance of about 0.01, no? Millimeter. Okay. Now for the forces, okay, member 1. Double click that. Shear bending. Okay, main bending is 38. Where's my Q1? Here. So I'm getting 3820. Okay, 3820. So 37 and 19.8. Almost 20. Okay, that's member 1. For the shear, so it should be 19 and yeah, the same, 19 and 19 because they're column. So I'll click on this. Okay, so the same, 19. Okay. For member 4, This is our member 4. And which corresponds to this member. I'll double click this. Our shear is 26. Okay, stats getting 26. My SMAT code, I'm getting 25.4. Okay, for the bending, I'm getting 44.34 in stat. And for SMAT, 43 or 44.32 point something. Okay. For example, let's try to find this one. 1, 2, 3, 4, 5. Member 5. Okay, I'll sample member 5. So member 5. So I'll copy this, then paste. Oh, I'll make this 5.
Katong allowance unta na ako ba?
I'll repeat. Q 5 equal. Yeah. So I'm getting, for the bending, no, 23, 26. Okay, stat is getting 24, yeah, almost 23, and 26. For the bending, shear, 17. I'm getting my SMAT 16.5. Okay. Say for beam. See, let's sample this. Okay. I'm getting 5.325. So what member is this? Member 13, right? So Q13. Q sub 13. Then equal. There will be a in beam because because we are neglecting the the actual, no. Yeah, okay. So I'm getting 5 and 25 here. I'm getting 16. Okay, both. For the bending, 27, 34. Yeah, 34, 30. Okay. And this difference also because you have concentrated load at this point. Okay. How about for member 13, 14, 15, 16? Try 16. And I'll change this to 16. Okay. Yeah. So bending is 25. Stat is 24, 26. Average 25. For the shear, 12.79. They're now the same. 12.78. Okay. Okay. So that's it. Let's now try final push. No? Let's make it 1, 2, 3, 4. Let's add another level, no? So that we can hands-on edit the code. Okay. So I'll save as this for story. Let's add another level. Save. Then geometry, and then I'll repeat this. Okay. Then translational repeat y 3 meters. Yes. Yeah. Then proceed to the loading. Yeah, so that makes it 40, 20, 30. So both 30 here. Hmm. I think this will be tedious now. Okay, so then I'll save as. Maybe I'll close this. Save as. So this becomes 4-story, 3 bay. Now, so how many members do we now have? 21, 22, 23, 24, 25, 26, 27, 28. So I'll make this 28. How many joints? 16, 17, 18, 19, 20. We now have 20 joints. So what's the size now of our matrix? So from 15 by 15 in 3-story, what's now the size? Uh, 1, 2, 3, 4. So additional 4 for the rotation, no? That makes it 19. Then additional sway for the fourth floor, 20. So this becomes 20 by 20. Yeah. I think this is the tedious part, no? Okay. So I'll add 1, 2, 3, 4, 5, 6, 7. We will add 7 data here. No? 7 datas. What if we delete na lang? 2-story na lang. Sige, okay lang. 7 data. 1, 2, 3, 4, 5, 6, 7. I'll disable calculation to save time. Add here. 2, 1, 2, 3, 4, 5, 6, 7. Copy ko to. Copy this. Then I'll make the columns first to be consistent. No? Copy this. 1, 2. Okay. Then we have additional columns. 1, 2, 3, 4. So I'll make this 1, 2, oops, 3, 4. Okay. Then this is the tedious part, the incidents, no? Because that should be consistent. One, two, two, three, three, 4, 5, 6, 6, 7, 7, 8, 9, 10, 10, 11, 11, 12, 3, 4. Okay. So instead of 1, 2, 2, 3, 3, 4, this becomes 4, 5. Yeah, this becomes 4, 5. Then 5, 6. 5. Ah, no, no, no. 1, 2, 2, 3, 3, 4. 1, 2, 3, 4. We have four columns. 1, 2, 3, 4. Okay. 6, 7. So this 6, 7. 6, 7, 7, 8, 8, 9, then 9, 10. Then 11, 12, 12, 13, 13, 14, 14, 15. Shift N. Shift S pala. 1, 2, 3, 4, 5. Then 16, 17, 17, 18, 18, 19, 19, 20. Then these are all the columns for the 20. Let me draw it first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I'll draw it now. Then for the girder, okay, I'll be starting now on the girder. This becomes 2, 7, 3, 8, 4, 9, then 5, 10. I'll paste this in our whiteboard. Where's the whiteboard? So you can see. Twelve, 16. Sorry. 5, 10. 7, 12. This is 7, 12. 8, 13. 9, 14. 10, 15. So last 12, 17. 13, 18. 14, 19. 15, 20. Yeah. So these are the incidents. Okay, we're done with that. Constraint. Constraint is 1, 2, 1, 2, 2, 4, 6, 8, 10, 12. So this is 11, 12, 14, 16, 18, 20, 22. Then 21, 22, 24, 26, 28, 30, 32, 31, 32. I'll pause share for a while. I'll open the image. Copy this and paste. Yan. Share screen. Yan. So this is the joint numbering. So this code is 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22, 10, 24, 26, 28, 30, 32. 2, 4, 1, 2, 11, 12, 21, 22, 31, 32. Oops. Yeah. So I'm done here. Okay, then calculate. Okay. Then I need to update this. Okay. So what will be the changes here? So I'll copy this first. Copy ko to. Control C, Control V. Then I need to tweak 3, 4, 3, 4, 5, 6, 5, 6, 7, 8. What? 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So 0, 0, 3, 4, 3, 4, 5, 6, correct? 5, 6, 7, 8, correct? 7, 8, 9, 10 is correct. Then this becomes 0, 0, 13, 14. So I'll make this 3. Sorry. Yeah, 3. Yeah. So this is the manual input I'll be overriding on the code. So then this becomes 3 and this is 5. This becomes 5 and 7. The lateral. These are the lateral displacement. This becomes 7 and 9. That's it. 0, 0 again, 3. Then this is 3. This is 5. This is 5. This is 7. This is 7 lateral. This is 9. Okay, this is 3 again. This is 3 and 5. Looks, I haven't completed this yet. Sorry. Okay, forgot something. Can repeat. Seven, 9, 3, 3 and 5, 5 and 7, 7, 9. 5, 7, 7, and 9. Then the rest, these are all the girders. It's become 0. Right? So I'll make this 0. Because girder, no vertical displacement. Make all this 0. I'll only activate the rotation. Okay. There should be no error. So far, no error. But I need to tweak something here. Okay, so what's the size of this? We now have how many displacement? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 by 4 is 16 plus 4, so 20. So this becomes 20. This is now 20. 20 displacements. Oops. So 3, 4, 5, 6, 7, 8, 9, 10. This will be 9, 10. Then 14, 16, 18. 14, 16, 18, 24, 26, 28. Then 30. Then add another 5 data. That will be 34, 36, 38, 40. Okay, that's it. Recalculate. What's our BU? Something is missing here. 14, 16, 18, 20. Ah, okay. I missed 20 here. 24, 26, 28, 30, 34. 36, 38, 40. There. We calculate. Okay, so next is the BB matrix. Okay, 1, 2, 1, 2, 3, 4. Okay, for maybe later. Let's focus here on the transformation matrix. The columns are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, up to 16. 16. Therefore, this will be 17. Then this will be 18. And this will be 17. Okay, Nels. Okay, the null matrix should be 20 by 1. Okay, and then my lateral load is located at I have a lateral load 1. Maybe I'll just apply lateral load na lang. 2, 3, 1, 2, 3, 4. Make this 1, 2, 3, and 4. Yan. 1, I'll make this 20. 1, 2, 3, 4. Okay. Therefore, in the STAAD, let's change this. No more uniform load. Okay, 40 is at 1. Okay. 20 is at 2. 1, 2. Actually, it's an ano. 1, 2, 3. It should be 3, not 2. 1, 2, 3, 4, 5. 5 is 30. Make this node 8 only. Node 8. What happened? 40 is correct. 20 is no 3. 30. Okay, analyze. Then calculate. It says here there's something wrong with our S matrix. My guess is in the BB matrix, most likely. I need to update the BB matrix because size of BU is equal to delete. What's the size of my BU? Hmm, so it's correct. Looking at our BU, I think it's already correct. 3 4 3 4 3 4 1 2 3 4. Yeah, it's already correct. My BB is incorrect because as you see, they have different size. They should be the same. No? So let's check on our BB matrix. Okay, I need to correct this. So 0012 here. Okay, I'll copy this first. Copy this. Then paste here. There. Then I need to verify here. Okay, I'll take a close look here. 1, 2, okay, 1, 2, 3, 4, 3, 4, 5, 6, 5, 6, 7, 8, 0, 0, 1, 9, there, 1, 9, 3, 10. That's what I'm looking for. 1, 9, 3, 10. 3, 10, 5, 11. This is, I need to improve yet on the code. 5, 11, 7, 12. 1, 13, 1, 13. 3, 14. 3, 14, 5, 15. 5, 15, 7, 16. So it can just copy this. Copy ko to. 3, 18, 5, 19. Oops, what happened? 5, 19, 17, 20. 2, 9. 4, 10. The rest are good. Okay, that's it. I think this is already good. And calculation, recalculate. Yeah, so no more error in our S matrix. So I think this is already good. I defined a QF here. I'll delete this because there's no member forces. Force along the ano. Okay, so this is my Q1. Let me see. 20 and yeah, 40 and 22. Staad gets 40 and 22 for the bending. I'm getting 38, 22. Okay, for the shear, 21. This one is almost 21. Okay, now for the column, okay, let me, for the column, let me extend my screen. Okay, let me check member 2. Double click. These are the shear, 8.3. So let's change this Q to calculate. Oops. And so 8.3. Shear is 8.3. In our code, we're getting 8.8. Okay, for the bending, how about the bending? 9.5 and 15. In our code, we're getting 10 and 16. Okay. How about the displacement? Okay. Referring to our displacement, so this should be displacement 1, 1, 4, sorry, 1, 2, 3, 1, 3, 5, 7. No, that's post-processing displacement. So this is our displacement, lateral. Okay. And this is our displacement. Displacement for member 1, for member 2, member 1, 2, 3, 4. I'll output the displacements for 1, 2, 3, and 4. Okay, then calculate. Then compare with stat. I see. So for member 1, our lateral displacement 127. We're getting 141. Okay, for member 2, we're getting 127 and 0.25. 141.27. Okay, for the third floor, we're getting 0.32. we're getting, where's our joint here? Yan. Okay. 2, 3, 8, 18. Let's look at 2, 3, 8, and 18. it's, uh, it's too short. There. 2, 3, 8, 18. 2, 3, 8, and then 18 is here. So 141.27, 0.35, 0.36. So we're getting 127.25. This one, well, comparable. 0.32. We're getting 0.32. STAAD gets 0.35. We're getting 0.34 here. Okay. STAAD gets 0.36. Okay. So very near, no, to our answer. Okay. Okay, basically that's it, no, displacement and member forces. That's what our so for the reaction, Q1, this is already the reaction, no? Q1, 20 and 38. So this is our reaction, 20 and 38, because these are the supports. Oops, sorry. Reactions. Yeah. Hmm. So what do I need to, that will be number 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. 9, 10, 11, 12, 13. So I'll be bringing 1, 5, 9, and 13. 1, 5. Oops, what happened? 9 and 13. 1, 5, 9, and 13. Calculate. There. So let's check on our actions here. 1, 5, 9, and 13. Okay, 21 as FX. Okay, 25 here, almost 25. And then 25 FX, almost 25. And 19, almost 19.5, or almost 20. Okay, and that should sum up to the horizontal load we applied, right? I think what are the loads we applied? 40, 20, and 30, right? Which is, so that will be 90 kilonewtons. So 20 plus 25, 45. Plus, yeah, 45 times 2 is 90 kilonewton. So the same. Okay, makes sense. For the moment, no, we cannot check Fy, right? Because we neglect axial deformation. So for the moment, 40. It's almost the same. 40, 43, 42. So our code gets 38, 42. Yeah, the same. 42 here and 38 here, 37 stat. Okay, that's it. I think that's already comprehensive. Okay. So do you have questions? Yeah. So maybe I'll resend again this code, no, for you to look at and study. No? But again, the whole concept is the same. No, the same with what we're doing since actual member. No? Get the member stiffness matrix to formulate the structure stiffness matrix. Okay. So with that, I'll just send you the copy of the recordings and the SMAP. Okay. So no more question and let's dismiss. Class dismiss and see you next week. Okay. Say goodbye.